Hi guys, here's another example of Gaussian elimination. Hopefully you have tried out the first two and maybe watch the videos on that. So if you want to kind of maybe follow a step or two and see if you can do this on your own. But I just want to mention what row operations we are allowed to do for matrices. And again, you just always have to remember that you are solving a system of equations using elimination. When we write them as a matrix, it's easy to forget that we have variables here. So you can't just like add a number to every entry in your matrix. And I'll show why in a second. But things we are allowed to do is add one row to another. Right? You can take one equation and add it to another as long as your variables are stacked. So my x's are in one column, my y's are in another, and my z's are in another, right? Because I can add, if the x's are together and we're using elimination for a system, we can always add or subtract the same variable. This also means that you can subtract rows, right? Since addition is just adding a negative. So I usually always do adding, but you can always subtract. You can multiply a row by a constant. That would be like taking a whole equation and multiplying it by 2, which is completely allowed. We could divide a row by a constant also, same thing as a multiplication by a fraction, so that's allowed. Another thing that's allowed is switching rows. So that would just be switching the orders of our equations. Let's say we wanted this equation to be first. We could swap those two rows and that wouldn't cause an issue. So I just want to show a couple, and like one main thing that is not allowed. We are not allowed to add or subtract a constant to a row. Again, remember that matrices represent equations. So let's say I had this second equation, 2x minus 8y plus 8z equals -2. If we wrote it as a matrix, it would look like this. It's really easy to forget that there's variables there. So if I say row 1 plus 1 and I get 3, -7, 9, -1, I might not think anything of it. But am I just allowed to add 1 to everything in this equation? No. I could add 1 to both sides, but if I add 1, what I did with the matrix here looks like I'm adding an x and a y and a z, and this is not true. So make sure you don't find yourself adding constants to any matrices. Okay, so let's get going with this example. If you guys want to try it out on your own, there's lots of different routes you can take when solving using Gaussian elimination. So I'm just going to do one option. I don't know if it's the fastest, but I kind of do the same things every time just to keep some sort of order. Some people try to avoid fractions. If it's easy to, I will, but otherwise, I'm just going to try it out the way it is. So my first goal, when I do every time, is going to be to try to get zeros in this first column. Now, initially, my first goal would be to get a 1 in the leading spot in the first row, but there's already a 1 there, so we're good on that. So now I want to get rid of the numbers below that. So to get rid of that 2 in the second column, second row, I'm going to use row 1. So I like row 1. I'm going to leave it. And I want to get rid of this 2. So I'm going to do -2 row 1. That would give me a -2 in that position. And then I'm going to add it to row 2. So again, I think about what this would be. This would be -2 times 1, which is -2. I add those together, that would be 0. You can always, use a scientific calculator for these or just carefully go through. So my second column, -2 times row 1 would be 6. I'm adding that to -8, -2. -2 times 1 is -2. I'm adding that to what used to be row 2. So I get a 6 there. Negative 2 times 4 is negative 8. Adding that to negative 2 is negative 10. All right, so I'm going to erase those helper numbers. Those are usually just what I think about. And if you want to kind of close up your matrix now and write row 3 and leave that alone for your first step, you can. But I'm also going to clear out this negative 6 here. So I'm again going to use row 1. Since I have a 1 there, it's really nice and easy to multiply. Essentially, the value you need to cancel. So I'm going to do negative 6 row 1. Well, actually, I need to do positive 6 row 1, right? Positive 6 row 1. We have to use the opposite of the value. Plus row 3. So if I did 6 times row 1, I'd get 6. Plus this original negative 6, that gives us a 0. That's what we want. 6 times negative 3 is negative 18. Plus 3 is negative 15. 6 times 1 is 6. Plus negative 15 is negative 9. 6 times 4 is 24. Plus 9 is 33. And I think my math's all okay. But otherwise, we'll have to come back and check. And that's why we write down those row operations. All right, so I'm going to keep going. I'm going to erase some of this stuff down here so I have some room. And now our first column is good. I've got a leading 1 and I've got zeros below it. So my next goal is going to be to get a leading 1 in row 2. So to do this, I'm just going to divide row 2 by negative 2. I want to get a 1 in its spot. Get my matrix set. I'll just do in colors what I'm changing. So that would be a 5 there. My first row is great. I don't need to change it because we have our leading 1. And my last row, I could actually change this one at the same time. And I have a couple options for how we can change it. We want this to be a 0. I'm actually just going to write it in for this one because it'll be easier to use my new row 2. So now my new goal is to get a 0 in this row 3 where that negative 15 is. So I'll rewrite the rows that are set. Now my second row is good. And I want to get rid of negative 15. I want that to be a 0. So I'm going to do 15 times row 2 plus row 3. So you guys try out this operation. Pause me for a second, see if your row matches. And I'm going to try to do it in my head and you guys can check. All right, I think I'm okay as long as I didn't make any silly math mistakes. But again, in my head, I was doing 15 times the second row and then adding that to row 3. So we had the 15 times the 1, 15 times negative 3, 15 times 5, and added it to my old row 3. So I have one last step now to finally finish up our Gaussian elimination and to get to row echelon form, which is I need a leading 1 in our bottom row. So my first and second row were good. I'm going to rewrite them. And I need to get this negative 54 to be a leading 1. So I'm just going to take the last row and divide it by negative 54. Squeeze it in there. So 0, 0, 1. Luckily, it goes into 108 pretty nice. Most of our examples should work out to be good integers at the end, hopefully. But not always the case, right? They don't have to be integers. So now finally we're all set. I've got z equals negative 2. I'm going to start subbing this into the other equations as I write them. Remember, this second one would be 1x minus 3. Oops, sorry. my second row is the y's. So it'd be 1y minus 3z equals 5. So if I sub everything back in, I have y minus 3 times, well, z we found is negative 2. So I'd have y plus 6 equals 5. Y equals negative 1. That would seem like. And I'll do the same thing one more time for this front, or this first row. 1x minus 3y plus 1z equals 4. So sub in what I have so far. X minus 3 times negative 1 plus 1 times z, which was negative 2, equals 4. So we'd have x. That's a 4 minus 2. So I think x should be, oh, I think I made a silly mistake looking back. It looks like we have an x plus 3 minus 2, so x plus 1 equals 4, and x should be 3. I always like to do a quick check at the end. So I'm going to take my second equation this time, 2x minus 8y plus 8z, and throw my values in there. So 2 times x is 6 minus 8 times y, which would be really 8 times negative 1, which will give us a positive instead of subtraction. And then minus 16. So it looks like we'd have 14 minus 16 is negative 2, and that was our second equation. So we're good with x equals 3, y is negative 1, and z is negative 2.